Hi, my name is Alexander Kamagin. I'm a founder and CEO of Adiom, where our mission is to make enterprise database migration and replication easy for developers and DevOps. In this video, we will do a live migration of a 50 GB database from a self-managed MongoDB version 7 hosted on GCP to the new Azure Cosmos DB vCore instance. We will use dsync for this migration. It's an open source tool that we at Adiom develop and support. While normally a complicated endeavor, dsync abstracts away all the complexity of a live production migration and allows to execute it in a single command. It supports all the common functionality required for live production migrations without needing the user to perform any complex setup, write custom scripts, or code. On a high level, a typical live migration process consists of the following 4 steps. First, we need to do the initial data copy from the source to the destination. Then, we need to catch up and replicate all the changes that happened during step 1 from the source to the destination. And we need to keep replicating them. When the source and destination are close enough, the user can switch the reads to the destination and stop the writes to let both the source and the destination get in sync. When they're fully in sync, the user can run a data integrity check and cut over to Cosmos DB. Let's take a look at it in action. This is our source MongoDB instance running on GCP. It has several databases. Today we will focus on the demo database, and that database has 2 collections, C1 and C2. Our destination is an M50 vCore instance in Central US, and it's absolutely empty. You can download dsync from our GitHub releases page, which I of course already did beforehand. Dsync needs to be running on a VM that has access to both the source instance and the destination. We will run dsync with a few specific parameters: the load level, the path to the log file, the database we want to migrate, the source, and the destination. Dsync offers a CLI as well as a web interface to track the migration progress. For this demo, we will use the command line. After starting, followed by a brief replanning phase, dsync goes straight into the initial data copy. That process is parallelized by splitting collections into smaller tasks. When the initial sync has finished, dsync automatically transitions into the CDC mode, where it continuously replicates changes from the source, starting from the beginning of the initial sync. When the number of events to catch up gets close to 0, it means the source and the destination are fully in sync, and we can run a few quick checks. We can check the number of documents on the destination and insert a dummy record on the source to see that it makes it safely to the destination. With no more writes at the source, we can run a full verification cycle to ensure data integrity between the source and the destination. Even when highly parallelized, complete verification takes some time, but it looks like we are good to go, and we can safely cut over to Cosmos DB. You can get more information about Adiom and dsync on our website and in our documentation. You can use this form to get in touch with us for commercial inquiries or to schedule a demo.